My name is Rick Busarow. I'm a senior Android developer at Milwaukee Tool in Milwaukee, Wisconsin. We make smart power tools, Bluetooth. If you're interested in that, I'll talk to you about it afterwards. But right now, we're here to talk about Koin. So before we jump into it, could I ask who here is using? Is anybody using Koin in any capacity whatsoever right now? No? Anybody using Dagger? Okay. Any other dependency injection libraries? Koin, Toothpick, manual injection, Spring, kind of counts. Juice, I forgot that one too. Okay, who here is an Android developer? All right, I've got some code samples that are Android, but this is pretty, doesn't need to be about Android. Okay, so we talked about that, and now, what is Koin? If you pay attention to Android social media at all, you've probably heard about Koin. Last few months, it's kind of a hot topic, whether it's dependency injection, service locator, whether it's worth using. It's getting a lot of attention. We're going to not really focus on that, but what we will talk about is that it is a library that's entirely written in Kotlin. It is open source, and it's pretty new. So 1.0 came out a little over a year ago by Arnaud Giuliani. Well, the author is Arnaud Giuliani. He's an Android developer, and decided that there's something better that we can do with just Kotlin to move away from Dagger. So he wrote this. It came out a year ago. And then just a few months ago, which is what triggered, I think, a lot of the revised talk about it, is 2.0 came out in May. And the way that I would characterize Koin is it's kind of like a MacBook Pro. This is a 2018 6-core MacBook Pro. It's really easy to use except for the keyboard, and it's more than fast enough for pretty much anything that you would want to do. It's a really, really great experience for everybody. And on the other hand, Dagger, not hating on Dagger, it's like a headless Linux server. It's got 2 processors, it's got 256 cores and a terabyte of RAM, and it's extremely powerful. It can do anything you could throw at it for forever, and it's going to scale really, really well. It's also using something that you learned in college and you haven't really been using it since, Linux or Java, and it's just not that fun to actually interface with at all. You do it when you have to. So that's how I would characterize it, and I'm going to pick at it a little bit throughout the talk. As a vehicle to talk about all this, we're going to have a little sample app. It's not going to be a coffee maker. We're going to have a single screen, which requires a single view model, and that view model is going to depend upon a user ID and a repository. And that repository is going to in turn depend upon a service and a DAO, and I mean retrofit and room. So the DAO is going to depend upon the room database, and that is of course going to depend upon the application context. And the service meanwhile is going to need a retrofit instance, which itself requires an OK HTTP client and a base URL. And let's look how we're going to build this using the normal control flow, or the normal control flow, which is legacy code. So in order to create our repository, we would again need reference to this DAO and this service. But in order to create them, we're going to need to create all of these other classes, the database and the retrofit instance and the OK HTTP client. And this is really, really expensive. It's expensive in a few ways. First of all, that OK HTTP client takes about 150 milliseconds to initialize on a modern Pixel 3. And it's expensive in terms of boilerplate. Now this is, like I said, it's a single screen app with it's not doing anything really, but if you're creating a lot of repositories, you'd have to hard code this code because we can't inject anything here. You'd be hard coding this into every single class. You'd be creating it over and over and over again, and nobody wants to type that. Every time you copy and paste it or type it, you're introducing risk for error. And every time you're copying and pasting it, you're introducing this risk. That means that you also need to test it. And if you have hard-coded dependencies at the edge of your application here, like you need an actual database and you need an actual retrofit service, how do you test those? You could, well, for the database, you could use Web Electric. For the API, you could either test against an actual API, which is beyond horrible, or you could use a proxy or a Wiremock or something, but nobody wants to do that. So what we're going to do instead is introduce an inversion of control. And this typically gets broken down into two different categories, which would be service location, or service locators, and dependency injection. What I mean by a service locator is you'd have a reference to some singleton within the class itself, and that singleton would then be responsible for either providing you an existing instance of your actual dependency or creating a new one for you. That's reasonably straightforward. And for dependency injection, we can break this down into two different categories. We have constructor injection, which is pretty much just parameters that you pass into a class. Everybody gets that. Or you have field injection, where you create this mutable property, which is then set after the fact. So we're going to talk about that a little bit more. So in Android, sorry for the non-Android folks, we have some core classes which we don't actually have control over the constructors on. Right? That would be services and fragments and activities typically. This is also something that you can see in so many different libraries, where either you don't actually construct it and you just provide an interface which is then constructed for you, and you have an object that meets your interface, or you have, say, activities where fragments where the class can be recreated at any given time, like when you rotate the phone, and the framework is only going to use the no-arg default constructor, so you can't pass anything using constructor injection. So what you're going to do instead is this field injection thing, where you have the mutable property, which we could make nullable, but then we were going to have .lets everywhere throughout our code, or we can just assign it as a label. Then, since this is we're requiring something else outside to do the injection, we would have some sort of injector object, which we would then be able to call, give it inject and pass it ourselves, and then the injector would be able to seek out the properties within the class which need to be injected and inject them via some means. So now, with actually calling that call, what we're going to do is hook into our lifecycle, whether that's an onCreate or an init block or onStart or onattach for fragments, whatever you can get to as early as possible. You'll be calling this injector object and say, hey, give me this stuff that I need. And I want to point out that the injector is not returning the property, because that would be a service locator. The injector is setting the property itself. The return type of the function is void or unit. And there are three problems with this, as I see it. First is that the late init var has to be public so that the injector can actually access it. And so in this case, this is a view model. The view model is an implementation detail of this class, right? The view model is responsible for performing business logic so that it can determine what the state of the view is going to be, which the activity of the screen is then observing to figure. It's not it's not a feature of the class. It's an implementation detail. But with these public properties, that view model can be accessed from anywhere. And then you would be able to drill down and access all kinds of things, which are just implementation details. This may be more of a style thing, a nitpick, than a real problem for anyone's normal application. But if you think about libraries, you're exposing this functionality to people that don't sit next to you, that you can't trust. And those end users will find every little, whatever they can do to make their thing work at that time. So I don't like that. Second thing I don't like is that it's mutable. Again, I'm picking on Android, but the concept of a view model is that it's persistent throughout the life of that view or of that screen, regardless of the configuration changes. That's their whole point. But with it being mutable, you would be able to set a new view model whenever you want. And not that you really want to do that, but you can. And stylistically, just don't stop. So then the third thing is that it's late init. And when it's late init, you don't really know for sure when it's going to be set. You might want to be able to access properties from the late init, and you can't. You might have an observer that's trying to reference this late init property before it's actually set. There's just so many problems that can happen because of late inits. And one thing that you could do anytime you wanted to access that late init would be to wrap it up in a lazy delegate. And this makes it less likely that you're going to have any problems. But now this view state, in this case, could only be accessed after the view model has been initialized. And which means that you're either introducing the exact same risk with the view state as you would have been with the view model, or you're introducing more lazy delegates, and then without actually using coroutines or RX, you're still creating this entirely reactive flow just by using lazy delegates in your class, all because you have this late init bar. So we don't like late inits. Let's go ahead and make this illegal state impossible and switch to constructor injection. This is the preferred way of handling dependency injection, and I'll show you why. First off, we can now make properties private. Because in order to create this repository, you need to have access to these objects from somewhere else. So in your testing, you're going to be able to get access to them from something else. And you don't need to make anything internal or public or anything else just for the sake of testing. But how are we going to actually initialize this repository in this case? So if we remember the graph, the repository is something that the view model needs. So in the view model, we could construct it, but it takes those properties, and the view model doesn't have access to those properties. So now we need to get those properties. And we could do this by creating the database, and creating the DAO, and creating the service in the retrofit client, or the retrofit in the OKHTTP client. But now this is the same as what we were doing before with the normal control flow. And obviously, we can do better. We can inject those properties themselves. Now, the view model has everything that it needs in order to create the repository. But, of course, the only reason why we're injecting those is so that we can create the repository. So instead, we can just inject the repository itself. But now, how does the view model get created, right? Well, in the screen, in the activity, this looks very similar to what we just had. It's the same problem, and the activity doesn't actually have what it needs in order to create the view model. We need to inject that, but we can't inject it using the constructor because this is one of those classes where we don't have control over the constructor. So instead, we have to go back to this late init bar, and this is what we do with Dagger, the reigning king of dependency injection. And I'm trying to make a point here, which is that dependency injection is actually just kicking the can down the road. It does not know how to create instances of things. It just knows how to pass them around. If we want to create instances of them, we need the other pattern, which is service locators. So, hooking back into Android again, what we would be doing to get a view model with Android is to use the ViewModel providers service locator. And there's a lot of stuff going on behind the scenes, but basically we're calling this ViewModel providers singleton provider service locator, and it's giving us the instance that we need. And because we're able to access it from outside, we don't need to make it public, and we can just make it lazy because it's not actually getting set. It's just a thing that we have. It's guaranteed at compile time. And that's pretty much how it works. But this requires a lot of knowledge about how how specifically the Android X lifecycle component works. You need to know how to build this reference, and it's kind of a lot of code to write over and over and over again. So wouldn't it be nice if instead we had some generic locator type singleton, another service locator, with a generic function, get, which could just figure out what we want and then give it to us without having to code in all that complexity over and over again. It might look something like this. Two things to point out here: it's inline and it's reified. And the way inline reified works is that Kotlin still has type erasure, same as Java. At compile time, we don't actually know what the type is of anything that's used within a generic property or class. But with inline, we don't actually create this function. If a function is inlined, then at compile time, all of the logic within that function is pulled out and put into the call site. So that call site, which might be looking for a list of strings, knows that it's looking for a list of strings. And even though the inline function is only looking for a list of T in the code that you're looking at compile time, it goes to that other place where we know that it's a list of strings, so it becomes a list of strings. So that's the magic of inline reified generics. Well, reified generics, which are only accessible from inline stuff. And so what that allows us to do here is, this code would not compile if it was not reified, but it is, so it will. We're able to check the type of that generic type T and determine what sort of class it is. And then we can do a lookup into a graph for that T, or we can just have a ginormous when block like this where we know the type and we're able to perform different actions depending upon what it is. So we could take this further and say, all right, well now we have a user presenter, and just add another line to our when block, and it scales very, very well. But a problem with this is that we're now locked into a single dependency graph, right? It's just moved around. It's kind of the same as normal control flow. But we can fix this by using something called the singleton objects interface pattern, where we have an interface with a companion object, and that latent var instance within the companion object is actually what is referenced in this get function. So we can create a locator with normal production code and use that from application on create, like the start of your application, throughout normal production code. But in testing, we can write a different locator and set that and use any test stubs or fakes or mocks that we would like. And that's really, really convenient. Somebody should write a library for that, and they have, and it's called Koin. So let's finally start talking about Koin by talking about Koin. And that's really confusing. But Koin is the name of the library, and it's also a class. So right now we're going to talk about the class. This is essentially the dependency graph and service locator of the entire library. I have a single graph here It actually has a lot of different graphs, but simplicity. It has functions for getting and setting those bindings and those properties, and it holds all of the logic necessary to construct anything that you might want. And then this Koin class instance is wrapped up by another class called Koin application. Koin application is, of course, the wrapper for the Koin instance, and then it also has some functions for setting modules, for setting bindings, and a couple of little convenience things, including closing the graph. One thing to point out about this is that it is not an Android application. Right? We have Dagger application, which is an abstract class. Your normal application would extend that, and that's not what this is. It's an entirely separate thing. I'll get more into that in a second, because we have this other thing called a global context, and this is pretty much what you would expect. It's reasonably similar to what I just described with the locator. It has this var for the Koin application, so this is what holds the global Koin application that you might want, and then convenience methods for getting that and accessing it and starting and stopping. So this allows us to have a global context, but what it also allows us to do is to have other instances of Koin. Because Koin itself is not a singleton, Koin application is not a singleton. So you can create multiple dependency graphs which exist in your app at the same time, which is really convenient it's really useful for very, very specific edge cases of handling wildly different scopes without having to do a lot of refactoring. So now let's get into some code that we actually write with start Koin and Koin application. These two things are basically the same thing. They're the builders for Koin application with two differences. The start Koin, oops, there's supposed to be a thing there. So start Koin has this global context .start. So this is the one that you want to use nearly all the time. When you're creating a Koin instance and a Koin application, and you want it to be accessible from everywhere, start Koin will set that to the singleton. And it also does this thing called create eager instances. Basically, when you're creating a binding, there's a flag you can set so that if it's a singleton, it will be immediately initialized without actually being accessed everywhere. So if you think about a large application which might have God classes or orchestrator classes that are actually just observing other things and they need to be up and running immediately, with Dagger you might initialize your graph and then immediately inject them into, say, your application class and do your initialization. With Koin, all of that's taken care of for you, and you don't actually have to have them as properties in some other object. And that's where the alpha is going to be. So now let's actually write some stuff. In our application class, first we would call start Koin right away in onCreate, and then we would add a line for Android logger if this is Android. And we do that because that's what every guide tells you to do. And this is what that looks like. Basically, Koin has debug messages, and normally they just go to system.out. But with Android logger, that all gets piped through our java.util.log. But I don't like java.util.log. I use Timber. It's a logging library. And so I looked at this code, and I said, let's go ahead and change it. Let's create our own subclass of logger and add Timber logic for it, and then make this factory function, which is what we're accessing from the start Koin, and now we can have everything go right through Timber. And it's really, really easy to do. It took a few minutes. And then I'm going to make a point about that later. So next, what we need to do, again for Android, so many things that we're creating in Android require an application context. There's a convenience function for that. Android context, you pass in the application instance, which has your application context, and that is actually our first dependency that we've added to our graph. And then finally, and I'm going to gloss over this, in order to add all of our bindings to the graph, it's just a single line, modules, and then you pass in your modules. So this Koin demo modules is a list of modules, and we'll talk about that in a minute. Because now it's time to talk about modules. To create a module in Koin, you just make a top-level val and use this module builder keyword. It's part of the DSL. So inside this module, you can declare a factory, which is another keyword in the DSL, and then you pass in the object that you want to create. So in this case, we're declaring a module which is capable of producing the user repository. By calling it a factory, it's going to create a new instance of the user repository every time it's accessed. And I've said DSL a couple of times now. DSLs they sometimes look like magic. This isn't magic. It's just a function that takes a lambda as its last parameter. It's a high-level function, and so it looks crazy, but it's really not. So long as it's returning the object that you want, you can do whatever you want in it because it's nothing special. But don't do that. And I've called these a couple of things now: dependencies and bindings. Really, in the documentation, the object that you're creating here is called a bean definition. But in Arnaud's talks and in a lot of other places, they're referred to as components. So now I'm going to start calling them components. Conceptually, this is nothing like a Dagger component. It's just a similar name. Modules, on the other hand, are conceptually very much like Dagger components. They're just logical groupings. There's no hierarchy to them. You can have as many as you like. You can have one, which is thousands of lines long, or one module for each dependency. Doesn't matter. So we've talked about how to create a single dependency, and now we need to let Koin know about it. I said I was glossing over this earlier, this Koin demo modules. It's just a top-level list, a top-level property, which is a list, and it was empty. And then we add our data module to it. This is similar to, again, in Dagger, using includes in a definition. Same thing. Now, since Koin demo modules is already being added to the Koin application, now the data module is part of the dependency graph. But this repository has dependencies of its own, right? We were hard coding them before, and we can clean this up considerably. We can move the service and the DAO into the constructor. And note that we can also make them private, since, again, we're going to have access to them in order to create the repository, so we don't need to get them from the repository. And now we've broken our module that we just wrote, because this is a no-arg constructor, and now it takes 2 parameters. So we can get those parameters from the graph just by calling get. Get will eagerly resolve the dependencies from the graph itself. And it's doing this without actually having to specify any types, because the repository constructor is very explicit in what it needs, right? It doesn't say, I need a service of type any or a DAO of type asterisk. It says, I need a user service and a user DAO. So that inline reified function works, and so long as we've declared those 2 dependencies in our graph, we'll be able to resolve them. But of course, now we need to get those dependencies, the dependencies of those dependencies. And here's what that is for the user service, right? We needed that retrofit instance and the OK HTTP client. And 2 things to point out about this For the retrofit instance, we're using get not in the constructor, but in this client function in the builder. Doesn't matter because get is not magic. It's just an inline reified function which works everywhere. And the second is for the user service, we're using get to access the instance of that retrofit instance without actually passing it at all. So it can be used just like a normal variable. Then we're going to do the same thing with the DAO, which requires the room database. And in this case, we're going to use the Android context that we added to the graph back in Start Koin, as well as using user DAO, which is a function in Java, but in Kotlin it just looks like a property. So what we're doing here is we're not actually creating an instance, we're accessing something from within our room database's generated class, and it will return an instance for us. So long as we can get an instance, that's all that really matters. So I wanted to make a point about this, which is that it's pretty difficult to read. Obviously, again, you can organize your modules however you like, but beside that, we've got stuff where we're explicitly declaring the type as part of the function call, and others where we're just accessing it from inside the function call, or we're even inferring it in the case of retrofit. And so anytime I'm writing a module like this, I make sure to just align everything so it's nice and legible in the same spot, and you don't have to go digging throughout the code. So the other thing that we ought to look at with this is the efficiency of it. Earlier I complained that these are expensive to create and we're creating them every single time, and we are still doing that here, right? We're calling factory for every single thing. And we don't have to because Koin has another keyword, single, which creates singleton references. Notice that we're not going to do this for the user DAO, because that user DAO is, again, just delegating to the logic that's already been optimized by Android, and we don't need to worry about it. Also, I'd point out that prior to Koin 2.0, single was called bean. So if you're digging through documentation and you see bean, you're like, what the hell is this? It's just single. And actually now there's a type alias, so you could continue using bean, and it's just single. So, so far we've been accessing properties from within the graph, but we need to be able to get stuff from outside the graph, otherwise there's no point. So, let's say we have a screen which conspicuously isn't part of any sort of class hierarchy, and let's assume that it needs a repository. We can access it like this. We can call global context.get, which would give us that Koin instance, and then .get again, and that would give us, that's that inline reified function, which would give us the user repository instance. But this is really gross. I don't want to type this. Fortunately, we have a shortcut. It's called Koin component. It's just a marker interface. And then there are extension functions upon Koin component to give us reference to the get function and some other keywords without needing to write all that boilerplate. But it gets better if you're an Android developer, because again, the author is an Android developer. Since Koin component doesn't actually have any magic, it's just extension functions, he wrote the same extension functions for activity by way of component callbacks. So it's actually, it works for activities, fragments, and Android services. And in the same way that he wrote those extension functions for component callbacks, there's nothing stopping you from writing those same functions for anything else, or even top-level functions, so that you don't need to use a marker interface. It's just that he did not do that. It's not a feature of the library. So now, our screen shouldn't be dealing with the repository, though. It should be dealing with the view model, and the view model should be taking the repository. So let's add the view model, which needs that repository, to our graph. And we can do this using a new keyword called ViewModel. And this is, again, Android specific, but the logic behind it is not. This behaves similar to a singleton in that anytime you call ViewModel, it's going to give you the same reference, but that reference is in a different scope than a singleton, and it's a different scope than a factory. And well, let's add it to our module, and then we'll look at the screen and see what that means exactly. So we were calling it with a get, which is eager, and it's bad. We can't do this because the view model needs to be linked to the lifecycle of the screen. What we can do instead is use a by view model delegate, and this is again an extension upon lifecycle owner and another Android thing, and it adds a listener to the lifecycle, bypassing view model providers entirely, and observes the lifecycle and just automatically destroys the view model when that lifecycle goes into the destroyed state. So no dealing with any of the legacy Java implementations. It just handles it all on its own, does the same thing, just a lot cleaner. Way, way, way cleaner. So what about if you wanted something else? The view model is a lazy delegate which only works for view models, but you can do the same thing with inject for any other class. It will, instead of resolving a dependency eagerly, it'll just pull it from the graph whenever you need it. This is kind of shorthand for doing by lazy with a get. And this can be used in component callbacks for Android classes, but it could also just be used with Koin components or by directly accessing that global context. So next up, we're going to talk about qualifiers. They're conceptually very similar to qualifiers in so many other libraries. Let's say you have two types in your graph, or two objects in your graph, which are actually of the same type. In this case, a coroutine scope. We have a coroutine scope that's using the default main dispatcher, and another one which is using I/O. But they're both of type coroutine scope. So Koin isn't going to know what to do about this. It wouldn't build. We need to provide some way for Koin to differentiate between them, and this is a property that you can pass into this factory function. It's the first property. It's called a qualifier. And there's a couple of different types of qualifiers, but the one which everybody uses for everything because it's convenient is string qualifier, where you just pass in a name. And now, if we wanted to access a coroutine scope from the graph, and specifically the main coroutine scope, at the consumer side, we would again just pass in that same qualifier, and now Koin's going to say, oh yeah, I know that you want the main coroutine scope. I'm going to give you that one with dispatchers.main. Now you can also say you can have one unqualified version and then a qualified version, which you'll see a lot in examples of like mock or testing, and that's fine. If you don't specify that you would want a mock one or a testing one, you get the normal instance, and then if you specify testing, obviously you get that one. So parameters. I love parameters. This is something that's been really, 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 really awkward for Dagger. So much so that there's a third-party library, pretty much written by Jake Wharton, called Assisted Inject, just to handle parameters. And by parameters, I mean runtime parameters. It's one thing if you can know at compile time that you always need this particular DAO or this particular view model, but what do you do about user input, or user ID, or something like that? And remember, back at the start, I said that our view model had two dependencies. There's the repository, and then there's that user ID. We have to add this to the module definition. How do we do that? Again, the DSL is not magic. It's just a regular lambda, and you can pass in this parameters object, which again, it's just a lambda, and it takes whatever number of parameters you specify, like so. So in this case, we want a user ID as a runtime condition, so that's one parameter. And then while it's constructing the view model, we're going to use that in addition to the repository, which we already know how to get. At the call site, instead of passing in empty parentheses, like you see with that by inject, we would pass in a lambda, and that lambda would have this parameters of object, which is just a regular plain old Kotlin Pojo object, which gets dereferenced to become this lambda. And that's really it. So now if we want to create a view model with a user ID of 50 cents, because Koin, we pass in that parameters of object and it'll know what to do. It takes it from there. So now let's talk about scope. We've already been talking about scope. We talked about factories and singletons, which are the two extremes of scope. And I didn't call it out specifically, but when we were talking about view models, we're also talking about scopes. It's a scope which lasts from the creation of the screen to the end of the screen. And that's something that we want. We want to be able to have scopes which are in between those two extremes. We've actually been creating scopes as well. So this is a screenshot of what the IDE is telling me. Every time we create a component, everything inside that component is part of the scope. Now that's a super overloaded term because what does scope mean? There's apply is a scoping function, or any function, a normal function has a scope. But in this case, we're talking about a specific class within Koin called scope. And things within that scope are alive until the entire scope is closed, and then they're killed off. And when I said that the view model is put into a special graph, the special graph that it's put into is a graph for that scope. So when we want to create a scoped object, we use a new keyword. It's called scoped. And so this is comparable to a factory or single or view model. And then we put that inside a scope set builder, where that scope set now takes, it's called scope name, but it's actually a qualifier, same as what we already talked about. And in this case, the classic example of scoping is a login session, right? And we've got that user ID, 50 cent. So what we're going to do here is create a scope using login. And so this scope will last from the time the user is logged in until the time the user logs out. And so inside this scope set, we declare any of the components which we want to persist only throughout that scope. And we can put however many components we would like in there. So if you had a diary, put that in there, and everything will be destroyed when the scope is destroyed. And of course, now we need to add that to our list of modules so that Koin knows what to do with them. So then at the consumer side, outside of the graph, what we would need to do is to create a scope using this create scope keyword function, passing it that qualifier of login, which tells us what type of scope it is, and then the other qualifier of the user ID. So now if we were to have another scope of type login with a user ID of something else, it would not get the same objects. And of course, when we're done with the scope, we need to close it in order to destroy these. So when the user logs out, this scope would need to be canceled. And in order to pass this scope around, it would actually need to be a property of constructors. And for Android developers, we get something better. We have another keyword called current scope, which will get the class type of the calling class and automatically create a scope for us. So this is what we use for behind the hood. This is under the hood. This is what ViewModels is using in order to create these their scopes. But it can apply to any other class where you use current scope and you'll get something specifically for that screen type. And then as soon as the screen is destroyed, the current scope is automatically closed. So, still talking about Android, there's a new feature called dynamic features, where we have modules which are load on demand for application classes, and this is really tricky because a module which does not exist at the start of an application cannot be loaded into the dependency graph for that application. As a matter of fact, the application level module has no knowledge whatsoever of that class. So what we do instead is in our dynamic module, we would create a feature modules type property of its own, and then we can create a lazy property within that module, and that lazy property, which now will only be executed once, the lambda will only be executed once, we would call load Koin modules, and we'd pass in the new modules for that module. So then this would be accessed from a function called init modules, and at whatever point is the starting point of that module, whatever activity that is, in its init block, you would say load modules, init modules, and now your entire graph is complete. So finally, we'll talk about testing. There are two things that Koin really, really shines at. The first is overriding modules. This is something which is extraordinarily difficult in Dagger. Dynamically creating different dependency graphs for different functions. So what we would be doing instead in Dagger, for our repository, we wouldn't actually be using Dagger at all. We would just create a mock service and a mock DAO and then inject that manually and perform our tests. In Koin, we have this keyword, this marker interface, Koin test. So we can use that in our test class. And it's similar to Koin component where it just gives us access to the normal graph. So now, in our setup function, we can use start Koin and pass in whatever modules we would like. And then in our teardown function, we would close the graph. And now we're able to create a new dependency graph for every single test. It's nice and hermetic. So now, we would be able to create a repository just by accessing the graph and not worrying about the dependencies itself. But I said overriding modules, and this isn't. This is just creating the same hard-coded thing. What Koin allows us to do is it gives us this tag for override, and by saying override equals true, which you can do at the component level, at the scope set level, or at the module level, anything within those curly braces will override anything which was already declared. So we can create our mock surface and our mock DAO, pass them into the graph. Everything else in the graph is going to use normal classes, and for the purposes of our repository, we will get those mocked instances. So, oh, right, and you also need to add it to the graph, which I already did. So the final thing is checking the graph. Everybody talks about the compile time safety of Dagger, and that's really great. It's great that you cannot build anything without all the dependencies that you need, except for when that doesn't work. But you can do that with Koin too, something that people don't really seem to know. There's a function called check modules, and it does exactly what it sounds like it does. It goes through every single component in every single module in your entire graph and make sure that nothing that you're saying you can create will fail because you don't actually have something defined for it. So this module, if we didn't have an OK HTTP client, everything would fail. It does check. This respects qualifiers, it respects scopes and scope sets, gives you everything you need. On the other hand, it does not check stuff outside of the graph. So this activity, which is accessing it using those delegates, would potentially have errors if, for instance, this diary wasn't contained. But this happens with Dagger as well, right? How many times have we seen crashes, those of us that use Dagger, where we're accessing something which is not in the graph? Dagger doesn't know how to check it, Koin doesn't know how to check it, it can't be checked. So, in summary, it's really simple. I just showed you everything it has to offer in 45 minutes. Any questions you can have can be answered just by command clicking on a function, seeing what it does. It isn't generated code. It's not magic. You can see all of it. You can see exactly what it's doing. And if you can't figure it out for yourself, there's amazing documentation to help you. It is safe. Check modules works. If you run any kind of CI at all, you're safe. It might be safer because you have these immutable valves instead of latent vars. It's extensible. If you don't like exactly what it's doing, if you want a convenience function, you can write it because it's not generated code. That's really it. Try it yourself. You'll like it. I promise. If you want to, here's some more reading. Documentation for Android specifically, documentation for Koin, that's the official stuff, for Koin Core, that's their GitHub, and these are the slides for what you just saw. Thank you so much. Again, I'm Rick Busarow. There's my Twitter, Medium, and Kotlin Lang Slack, and that's it.